Hello, everybody. Welcome to the Built on Casper with Make webinar. Um, Finally, we're happy to have it today since we had to postpone it previously. We've been looking forward to meeting with this group of developers for quite a few months now. My name is Michael Stoyer. I'm the CTO of Make. As most of you will know, Make provides a lot of sort of critical infrastructure in the Casper ecosystem. I'm guessing many of you will have used some of our products over the years. I'm also joined here today by Igor Burlachenko, the VP of Engineering for Make, who will lead part of the presentation, and David Hernando, Director of Engineering at Make, who will also lead part of the presentation today. Igor, would you mind starting the screen share?
Sure. Okay, let's play it.
Thank you. So just a very brief intro on some of the things that Make provides to the ecosystem.
Do you see my screen?
No, it says loading.
It says your screen sharing is paused.
So while you work that out, actually I forgot to mention some things. Throughout this webinar, we can answer questions. There's a Q&A functionality in Zoom, which you'll find on the bottom bar, and post your questions in there. Whoever is not speaking at the time will either try to answer them in chat, or if they are relevant to the whole audience, a speaker will address them either during the sort of allotted time or afterwards if there's still plenty of questions left. But your questions will be answered. And I believe also there's a raise hand function. I mean, most of you will be familiar with how Zoom works. Just interact with us. This is going to be an interactive webinar, and we're looking forward to answering any questions you may have. So real quickly, some of the things that Make has been providing to the Casper ecosystem is this collection of CSPR tools. We'll very briefly go through them. CSPR.live, the network explorer for the Casper network, and essentially the front door for many users into the network, from where they'll discover the applications that you're working on as well, to the extent that they have on-chain activity. The Casper wallet, a cross-browser and cross-platform wallet for the Casper blockchain, available on all major browser platforms on desktop, and all major mobile platforms, obviously, as well. CSPR.market, an NFT marketplace. CSPR.studio, a no-code solution that you could use to mint your own NFT collections on the Casper network through point-and-click functionality. And with a simple click of the button, also list them on the CSPR.market, or not exclusively, you can take those collections and list them on any marketplace. And as of last week's integration announcement with XP Network, you can take them to other networks as well. CSPR.click, an authentication layer that provides integration not only with Casper Wallet, but all the wallets in the Casper ecosystem. On top of that, it comes with social login and on-ramp integrations out of the box, meaning as a developer, you can essentially not care about all these things anymore and have a single integration. CSPR.live, CSPR.market, and CSPR.studio all use CSPR.click, so we drink our own Kool-Aid, as they say. CSPR.cloud is an enterprise-grade middleware layer aimed to make developer lives easier when building. It powers all of the previously mentioned applications, and it really started as an internal API for our Casper product suite, which we then opened up for everybody to use. And we'll talk more about that in this webinar as well. And then CSPR.build, which is a self-serve console where you can create and manage your CSPR.click and CSPR.cloud keys and access analytics and some other functionality, which we'll touch on. And currently, we are also working on CSPR.name, a name service on the Casper network, which will be released later this year, in fact, in the next month. Once released, CSPR.name resolution will be automatically added to all of our Casper products, and CSPR.cloud will provide an easy integration for any dApp which would want to use it. But today specifically, we will talk about CSPR.click and CSPR.cloud, products we created in order to make building on Casper easier, and also actually a little more fun. We will also go a little bit beyond that and talk about what problems we are trying to solve on blockchain. And we hope that this will influence how you approach blockchain, and together we will all build a successful ecosystem on Casper. With that, let's keep going. At the end, we will show a demo of a dApp that consists not only of a smart contract, which is built with the Odra framework, which works, as we'll touch on, very nicely together with Casper Cloud and some of the other solutions, but also a web client and the server-side part. Could be a good starting point for those of you who want to build your own Web3 application and are looking for an example. And this example is available to anybody, fully open source, essentially sort of like a kitchen sink app, if you will, that integrates smart contracts with Odra, Casper Cloud, backend functionality, and Casper Click front-end functionality. So as you can see, we are pretty active in the Casper ecosystem, and truly our commitment and our goal is to make blockchain convenient, both for users, end users, as well as for developers, and obviously all this on the Casper network. From this point, Ior will take us forward, and we'll tell you what that means in practice. Go ahead, Ior.
Yeah, thank you, Michael. So once saying we want to make blockchain more convenient, what we actually mean, we want to make it simpler. So at this point, both users and developers still face a very challenging onboarding process, and it shouldn't be like that. So over past 15 years, blockchain technology evolved dramatically. So we added smart contracts, we improved consensus algorithms, like the whole new development ecosystems were built. But we didn't really do enough to make blockchain more accessible. And one of the reasons is that blockchain kind of lacks one shared clear definition. So many people see it differently. And that understanding often doesn't provide information how to use it and what blockchain actually is. So for example, I made a note how Wikipedia defines blockchain. So it says, it's a distributed ledger with growing lists of records, blocks that are securely linked together via cryptographic hashes. So while technically correct, this definition doesn't help the reader why they need blockchain, how to use it. So it's kind of hard to imagine that somebody wakes up like a user in the morning and says, hey, it would be nice if the game I'm playing had a distributed ledger with growing list of blocks. Like same goes to business owners. So it's like hard to imagine that somebody would think about that. So we at Make, we define blockchain as a data storage that provides data we can trust. So that's kind of very generic definition, but it highlights two parts. So first, it says what it is. It's a data storage. And two, it distinguishes it from other data storages. So it's not like traditional databases cannot be trusted. They don't lose data whatsoever, but it's more about the environment, how they are operated. So for example, a company that controls the database can be incentivized to manipulate the data. A malicious employee at that company, for whatever reason, can manipulate the data. Simply some software issue could manipulate the data, and you cannot be sure that what you wanted to be stored is actually stored in the data. So we see trust as like the most important property of blockchain, and that's the value we want to communicate to the users. But that's not enough. So we also need to make interaction with blockchain more convenient, and it it means that we also need to teach users some new mechanics that are essential to blockchain and cannot be overcome like in a different way. So like for comparison, let's take a look at the internet. Right? So it's a fairly complicated technology which everybody is comfortable with. Right? So it's nobody knows about networking layers, routing hardware, and so on. But everybody knows how to use it. And the reason is that internet is known by its simplified model, like request response. So you make a request and you receive a response. If I know your web page is not loading, you don't receive this response, like everybody knows they need to check their internet connection, Wi-Fi, and so on. So it basically where we want to get with blockchain. So let's continue. So since we defined blockchain as a data storage, so let's see how users interact with the data storages. In traditional Web 2 interactions, applications, they simply don't. So there is always some kind of like middleman by design, some API that takes requests from the users, does its logic, and stores the data. So there is no way for end users to verify what was stored as a result of the requests. So in blockchain, there is no such middleman. Users interact with blockchain directly, and they sign the request to prove their identity. So there is kind of nobody in the middle who would modify the request that came from users, and users can verify it on chain. And signing the request is basically one essential mechanics that users need to learn. So they know that blockchain increases trust to the application they're using, and it means that sometimes for some operations they would need to sign the transaction. Let's have a look at the developer side. So traditionally, applications, when they interact with storage, it's like a simple model. You store the data, and later you can retrieve it. And that's kind of essential mechanics for storages that is typically presented like as a hello world example for whatever database you look at. I don't know, if you look at MySQL, Postgres, you first would learn about like some select and insert queries. The situation is quite different for blockchain. So it's kind of really hard to get to the point how you as a developer can use blockchain when you start learning about it. So you learn about Merkle trees and so on, which typically don't mean much for new developers. So that's like something we need to change. So let's take a look how interaction with blockchain changes this picture. So since applications don't make a request to blockchain to initiate transactions, users do that. Applications need to have a way to observe changes that happen. It could be polling, it could be some streaming solution, but essentially there is typically like some on-chain logic and off-chain part that is observing it. So I probably would could add one more arrow on the left that presents data to the end user, but that's not something that usually happens. Sorry, that often happens. Sorry, it happens for all applications. So let's not do that. So that's a new Web3 architecture, and when speaking about our tools, that's where Casper Click and Casper Cloud come to the picture. So Casper Click handles user interactions with the chain, and so you could also call it as kind of client-side solution for developers. And Casper Cloud handles server-side interactions, which basically means how you observe blockchain, or like in a more generic way, how you retrieve data from chain and react it correspondingly. So David will take it from here, and will introduce you to Casper Click. So I'll stop sharing and we'll transfer the data. David, you're
muted, David.
No, not now. Okay, I will start sharing. Let me. Okay, you should see my screen now, right?
Yes.
Okay, so let's talk a bit about why we would want to use Casper Click and what are the benefits of using it. So afterwards, we will see in a short demo how we can quickly start a project based on our templates. But first, let's introduce a bit what do we get when using Casper Click. Integrating Casper Click means first, using one single SDK to integrate with all available wallets in the Casper ecosystem. This relieves you, the developer, from the burden of learning the peculiarities of each wallet API, as we provide one single API that handles all the complexity of talking and managing each wallet's API and internal state. As you can imagine, this dramatically reduces your development and maintenance efforts. It empowers you to focus on the core of your application. On the user side, you can ensure that your audience can authenticate and connect their wallets to your application, reducing bounce rate and frustration. For this, we've built a simple and polished UI to interact with the user, ensuring a seamless and enjoyable user experience. Most of you are familiar already with this user interface because it's on Casper Live, it's on Casper Studio, on CSPR suite applications, but also on some customer applications. Believe me, because it's not trivial to reach the point where connecting with different types of devices, and you can take Ledger as an example, is simple for the average user and comfortable and comparable in some way to entering a user and a password like the user would do in a Web2 application. To do it robustly, we need to guide the user through the device connection, the unlocking, the opening of the Casper app, and selecting an account, etc. And similar to MetaMask or other wallets. So a well thought out and prepared UI is essential. When we provide same experience on different apps from different teams and organizations, we are making things simpler for the user. And consequently, we are increasing user retention and improving the perception of Casper as a friendly ecosystem. During the demo, we will see that while the UI comes by default, there is some room also for customization and adaptation to the requirements of the app you are building. For example, you can include or not include the top navigation bar. You can include custom account menu items or define your own application settings and display them next to the default ones. We are also including a set of predefined themes in the new version that we will release later this month and make it easier to customize colors. So imagine, let's say that a red color theme fits better in your application than our default blue. Then you can switch to that red theme by selecting it in the code. Apart from wallets, Casper Click also provides out-of-the-box integration with multiple fiat on-ramps. Fiat on-ramps that the user can use to buy CSPR and top up their accounts to start using the application quickly. It supports multiple regions, multiple currencies, and it's very simple to use for the user. And the third feature I want to highlight today is the single sign-on experience that makes switching and connecting between different apps super convenient for the user. Casper Click remembers the user accounts and suggests that the user connects with one of them when he lands in a new application. Next, let's talk about how we want to improve the onboarding experience on Web3 apps for massive adoption. And we are doing that with social logins. So when the average user is not familiar with blockchain and wallets, the onboarding process in a web application can be very painful. We need a better solution that first, having to download a browser extension Second, handled seed phrases. Or third, frighten the user into keeping this list of words safe, or he may lose his funds. With Casper Click, users can get a self-custodial Casper wallet without installing anything. All they need to do is authenticate with a Google or an Apple account. Then Casper Click creates a new account with an associated keeper, or if the user already has a previous account from previous session, then Casper Click retrieves public key and connects the account with the web application. This onboarding process is not only fast, but also very convenient and easier for users. It provides a well-known user experience. Moreover, the user starts enjoying the application first, and he can take care of the security of the account or make a backup later. For these accounts, we are providing also a web wallet for performing basic operations. That's what we see now in the slide, such buying CSPR, receiving or sending tokens, viewing activity, or managing the security of the account. Transaction approval is protected with second-factor authentication. This means that in addition to authenticated with the social login provider, when the user needs to approve a transaction, he needs to enter an unlock PIN that will release the private key and let the application sign the transaction. We are working to make this social login functionality available for all applications in a future release later this year. We will include it in the same SDK as we offer today for the rest of wallets. So there will be no need to change anything on the application side. It will appear as a new type of wallet in the wallet selection screen. Now I would like to show social logins in BizLeak game. So BizLeak is a mobile game built by Astronomica, and Astronomica built their own authentication system. They call it Astronomica ID. And since it's a mobile game, it also integrates with Google Play services and Apple Game Center. So when the user wants to open the wallet, all the flow is built in a way that he doesn't need to re-authenticate. Just he clicks on Go to Wallet, and a web browser is open, and the authentication happens under the hood to go from the Apple service identity to the Astronomic identity to the Casper Click identity in a way that it's very fast and simple for the user, and he doesn't need to re-authenticate. Okay. Now let's start with the demo part. Or maybe let's answer some question if there is any.
I currently don't see any questions in the Q&A. Yeah.
Okay, then let's start with the demo. I will open my browser and we'll go to the documentation site, because the easiest way to start a web application with React.
You're not sharing your screen anymore, David.
Okay, sorry.
There you go.
Now, okay. So now I'm on the documentation side, docs.cspr.click. I was saying that the easiest way to start a project with Casper Click is by bootstrapping a new React project from a template. So copying this create React app command, we will get a new React application that has already Casper Click integrated. This takes 40 seconds, less than a minute. So in the meantime, let me explain something about the application ID. Because when you are developing an application with Casper Click, you need an application identifier. And this templated project that we will get has or uses by default the Casper Click -template application identifier, and that's fine. You can use it as long as you are developing on your local machine. But as soon as you want to deploy this application to an online server, you will need your own application identifier. And later on in this webinar, we will talk about Casperville. That's how you can get your own application ID. Let's back to the terminal. The project is created, so let's enter the application directory and start the project. So right now what we get is a templated React application that has Casper Click integrated. And as such, we can see that we have the top navigation bar, which results familiar from other CSPR applications. We have the CSPR products menu to cross-promote between different apps. We could have cross-promotion agreements to show your application here. We have different settings that you may or not use depending on your needs. And we have this one-click pop-up sign-in model that appears because I have used Casper Click before in other applications. So what Casper Click is doing now, it's proposing me to use one of these previous accounts that I have used before to connect to the application, and just in one click, I'm connected. So now the state of the application has changed. I see a different content, and I see that I have logged in with this account, and I have an account menu, which has some default menu items like view my account on Casper Live, or copy my public key to switch to another account. But also we can here customize and introduce our own options. So for instance, for this template project, we introduce as an example a menu item to go to the Casper Click documentation. We will see later in the code how to modify this.
Can I interrupt for
yes.
1 minute, David? I just want to point out how powerful one aspect is of what you just shown, specifically the fact that this is a new application that you created literally a minute ago, right? And as a user, you subsequently visit it, and unlike essentially any or all of the applications that all of us are used to in the Web3 space, where as a new user to a new application, you would have to go through a fairly complicated wallet connection flow in order to first start using it. With Casper Click, within the Casper ecosystem, as long as your user has previously logged into another Casper Click powered product within the Casper ecosystem, which is many or most of them at this point, including obviously the main Block Explorer and other tools. Your user won't have to do anything more than essentially decide which account of their existing accounts they want to use with a single click, and they're logged in, and they can start using your application, which as application developers, we're all the same boat. Like ultimately, it's about converting first-time visitors into long-term users, and bounce rates will help determine that. So the easier you make it for your new users to start using your actual application, the lower your bounce rate, the higher your retention, and the more users you end up with. I think this is a pretty significant innovation within the Web3 space that puts Casper applications or dApps really gives a leg up compared to others. Back to you, David.
Thank you, Michael. Okay, so continuing with the templated project, once we are logged in, we see that the content has changed, and this is just a brief introduction to what we should do next, which is getting familiar with Casper Click. So we have some introduction to what is the use click ref hook, which gets a reference to the Click SDK. We can use this reference to the Click SDK then to, for instance, get the active account from the user and display it in the web page, which is what we do here. So this piece of code results in this table here. We can customize the account menu as I explained before, and we can customize the settings we see here. And for doing that, I will open Visual Studio Code now to take a brief look to the code of this template application. So I will open first the index file. In this index file, we define what I explained before, the application ID. This is important, as I said, Casper Click template will work while we work on localhost. For deploying our application, we need to get a new or our own application ID from Casper build. And then on the application component, we have the definition of the click top bar. And inside of the click top bar component, we have all the settings that we can customize. So for instance, here we see the Click UI component, and we see that we are including language setting, currency settings, or network settings, but I could easily remove these settings from the Click UI component, and then they are not here anymore. If we don't need the theme switch because our application only has one theme and it is a dark theme, then we can just remove the theme selector, set the dark theme as default, and we will get only one theme. And I need to remove the theme selector from somewhere. I did already, right, on theme switch. Okay, I didn't save the file, so the theme selector is not there anymore. We can change the configuration of the account drop-down menu. Here is where we are introducing a custom menu item to go to the Casper Click docs. Let me show something different with the Casper by Casper menu item. So by introducing this default component, I get this by CSPR option, which allows me to display this functionality of buying Casper with one of the multiple offered on-ramp providers like Topper or Ramp, seeing different exchange rates depending on the provider, different commissions, the quantity that I'll get depending on which provider I choose. And what else? Basically, that would be a brief introduction. What we need to do next is come back to the documentation side, open the React documentation guide and go through it to understand how to modify or customize Casper Click to adapt it to our requirements. So what if our application is not built with React? And we have a couple of examples on our products. One is Casper Studio, and second is the DevNet Explorer for the Condor DevNet. This is an application built with ASP.NET from Microsoft. So this is not a React application, but we can still integrate Casper Click and use it as normal. So with all the functionality that we offer. So how do we do this? We have a different guide on the documentation side. Basically, we call it JavaScript because it's the raw JavaScript and it can work for any web application. Basically, what we need to do is to add a script tag to download the Casper Click library, the runtime library. At the end of the head section of the index HTML page, define an empty div element where we will inject the Casper Click UI. This usually should be on the very top of the body. Configure the initialization of the Casper Click SDK, defining which is our div element, if we want to show the top bar or not, and this can be extended, and there is more documentation in the following pages. We can define here which settings we want to show, which themes we want to show, etc. And finally, we define what is the application name and the application ID, as discussed previously. And only doing this and also listening to the events that Casper Click is emitting, we can integrate Casper Click in any type of application. And just last word about events. So we need to define event listeners for the Casper Click triggered events to respond and adapt our application state to the different changes that Casper Click is communicating. And basically there are 4: when the user signs in, when the user switches the account, when the user signs out, or when the user disconnects a wallet. I guess that's all for this short demo. Igor, do you want to continue with Casper Cloud?
Yeah, sure. Yeah, let me screen share. You see my screen?
Yes.
Yes.
Yeah, okay, cool. So yeah, what's Casper Cloud? Casper Cloud is a middleware layer for the Casper network, and it basically indexes all blockchain data and normalizes it to make it easier for developers to access and use it later. So basically, we try to do most of the heavy lifting and cover most of the basic use cases to make the development on Casper easier. Yeah, and basically, since you can retrieve the same data from Casper Node RPC API, I just want to quickly go through some examples why having a middleware layer can still be useful. So, like first issue you face with blockchains that they are not typically optimized for advanced search functionality, right? So blockchains optimized for transaction security, for peer-to-peer communications, and so on. Advanced querying possibilities are typically out of question, and indexers come to the rescue. So let's say if you want to say like who interacted with the auction contract in April this year, you'd basically need to traverse all the deploy transactions in that period of time, if you're lucky, like can you pick proper block height, and see which one of them actually called the auction contract. And I made this example with the auction contract, but like the same applies to any custom contract developed by you. So second kind of related issue that often to get all the information you need to make multiple requests. I know you can imagine that you want to display proper balance and symbol for a fungible token contract, and to do that you would need to make kind of 3 requests to read contract name, to read its proper decimal points, and to read the symbol. And another bigger issue, so when your application grows, scaling is challenging. So if you try to scale horizontally by adding more nodes to power your RPC requests, the distributed and centralized nature of blockchain may cause data races. So it basically means that if you ask the same data from 2 nodes, in some cases, sometimes you may receive different responses. So typical use case would be that like some data is already available on one node, and on another node it's like not available yet. So it will be there just like moments after, but it can create lots of inconvenience for the end user. So what indexers do, they basically store the blockchain data in appropriate storage suitable for searches. And scaling with an indexer, you can scale API horizontally. You can kind of add more servers. You can also scale database horizontally, right? So you can like add some read replications. So it's kind of more safe and robust, and provides more reliable access to the network. And I'm not even mentioning like the costs, right? So in infrastructure costs. For the middleware, use this like economy of scale approach, and you basically don't need as much hardware. So yeah, so what is Casper Cloud in general, what it provides? So it consists of three main parts. So one, we have data APIs, which are REST-based, and they provide a low latency access to normalized and indexed blockchain data. But not only blockchain data, we also cover user land contracts like fungible and non-fungible token activity. We fetch historical pricing data, related off-chain metadata for NFT tokens, and other data you may need. For most of the data pieces, we provide corresponding streaming API via WebSockets. And like the main point of a streaming API that you can subscribe granularly to only the updates you're interested in. So you don't need to listen to all deploys and filter out only what you need. You can say, hey, I just want to receive on-chain event from my specific contracts. And of course, Casper Cloud provides access to Casper Node RPC API, but it is enhanced with a caching layer. So on average, it provides lower latency than just a normal Casper node. So I will not go into all data APIs in this presentation, but I want to show you some like nice examples that show what Casper Cloud can do, and they also will help you to kind of extrapolate it to more use cases. So yeah, so if we begin with indexing, and let's start with indexing just like basic data as deploys, we already see that it can be challenging, because on Casper you can call a smart contract in 4 different ways. So you can call it by contract hash directly, you can call it by contract package hash, like for version contracts. You also can call a contract by an alias that you specify for that contract, and the same, you can specify an alias for the contract package. But that's kind of already 4 use cases to cover. So ideally, you'd want to normalize the structure to one form, and that's precisely what Casper Cloud does. So all deploys are provided in this format, and we have contract package hash, contract hash, entry point, and how deploy was called, if you're interested, is provided in the execution type ID property. So searching. So obviously you can filter, and filtering happens in a predictable, RESTful way. So you just add a query parameter. So in this example, we ask deploys filtered by contract package hash, and we specify the contract package hash. We can filter by multiple properties. So we can ask for deploys that call specific contract and called by specific caller account. Next, just to avoid this multiple requests issue to collect more data, Casper Cloud provides possibility to include related data in responses. So for example, deploys contain some identifier information like contract package hash, entry point ID, and for all data types that have IDs, you can include the corresponding entity. So you do that by specifying the includes query parameter, and you just specify comma-separated list of the corresponding entities. So here we want to include contract package and contract entry point, and that's basically what you get. So our response was expanded with new data. So I did not show full contract package because like I didn't want to make the font too small, but for entry point, we see it's basically entry point object. And what's the most interesting piece for us, it's a mint entry point. So you can go further. You can include rate data. So a rate includer is a special one. It's a function. So it accepts currency ID. So currency ID obviously can be retrieved from the API in a predictable way. So it's just like /currencies. One corresponds to USD. And if you add this include, you'll have a new property in our response called rate. And what's nice about that it is rate that corresponds to the timestamp included in the entity. So we know that Casper rates fluctuate, like blockchain token rates fluctuate, and in most cases you're interested in the rate at the moment when the event happened, not like current rate. So another kind of complicated topic. So we know that on Casper accounts have two identifiers. So public keys, which are mostly used by end users, and that's what they typically want to see. But there are also account hashes that are used internally by smart contracts. And the reason behind that is that since Casper supports multiple hashing algorithms, cryptographic algorithms, they can have different public key lengths, and internally you want to have a fixed length type, which is account hash. But the side effect of that in some cases, when you want to access the public key, you cannot do that because there is transition from public key to account hash, which is basically just a hash of the public key. But there is no function that will translate account hash back to public key. So what we do, we index, we maintain an index from known public keys to account hashes, and you can use it. So this is a transfer response, like transfers like internal smart contract side effect, and it has account hashes. So, and if you want to know public key, you just like follow the same approach. You include it as an optional property, and in this case, it's called toPublicKey, and it will be injected as a response. So similarly, like you see in this response, there are also purses, and on Casper you can send transfer directly to the purse. Like you can omit those parameters at all, so they will be null. So we do the same for account purses. So you can de-anonymize account purse to the corresponding account, and if you want to know its public key, just same approach, includes an optional property. So I hope you already see the pattern. So if you need extra data that is related to the entity, you should check what optional data you can add to your response. So in case of purse, so we will translate this purse to the corresponding public key. Yeah, so those are like some of the features. I cannot go through all of them, but I invite you to Casper Cloud documentation website. And here in the REST API section, you can see all of the data we provide. And you can see it's not only blockchain data, like I just showed you, but we also provide data about fungible tokens, non-fungible tokens, and it's just for non-fungible tokens, we provide index of tokens, of token actions, which is basically like history of what happened to each token through its lifetime, and even ownership. So you can get a list of all tokens owned by an account or owners or holders for a specific contract, like same for fungible tokens. So you can expand each specific data to see what endpoints are available. And so actually, let's check the deploy page. So you would see properties for that data, but there's also this optional property table, so you know what you can include. So there are also examples at the end on the page for each endpoint. So you can just like copy and execute it in the terminal, just to play with it. Know that this is a shared public access key. So it has lower quotas. So you may want to swap it with your own if you don't receive responses. And as I mentioned, all those data, most of it have corresponding streaming APIs. I would say like the most interesting one out of those for developers would be contract level events. So you can contracts can emit events to notify the off-chain part that something happened, and those could be consumed. So you can just subscribe to the streaming API and listen to updates from your smart contracts. So most of the examples I just showed you are also available in the highlights section. And for contract events, there is a script that you can follow and test, try contract events using the Casper Studio application. So you'll mint an NFT and receive a corresponding event. A couple of other interesting functionality I didn't mention. So we already provide possibility to resolve Casper names. So if you're a developer and you have an existing app, you can prepare for the launch in advance and start supporting Casper name resolution before it's officially launched. And another one interesting piece that I really like, it's about NFT data. So often developers decide to store NFT metadata off-chain, like on IPFS or like a different storage, just to optimize costs. And Casper Cloud fetches that off-chain metadata for you and returns it in the response. So very convenient, and if you tried doing it yourself, you know that IPFS can be super slow. So like having API from Casper Cloud is very convenient. So for the demo, as I said, we want to show you listening to contract level events, but we actually will do it with the demo application. So I have it opened in a different browser here. Do you have any questions? Michael did.
I don't see it. Sorry, go ahead.
I was going to say we have a question from Gokai about Casper Click that we can answer later.
Okay.
And so far, no question about CSPR.cloud.
Okay, so let's look at this demo application. We created it to have an example for developers, especially new developers that want to have a starting point, just to start their journey. So that's the starting point you're looking for. It's a lottery, and we
hold on, Eeyore. We actually do have a question
Sure.
from an anonymous attendee that relates to Casper Cloud, and it is as follows. I have one question. I am stuck in event parsing, and I don't see any example or sample code on how to use CES Go parser for event parsing.
Okay, I believe it should be available on GitHub. Just like. Here, and there should be this. So there should be an example, yeah, here in the README, and it's basically it. It's like that simple. Yeah, here you receive a list of events, and if you have any questions, you can ask them in the developer Telegram group, and yeah, we'll help you. So that's just under the Go Casper test parser GitHub.
Thank you, Eeyore.
Yeah. Okay, so back to the demo. Actually, you already see it looks very similar to Casper Click template, and that's because we used Casper Click template to bootstrap the application. We tried to not change much, so to keep it really simple. So it really looks very similar to the template. So it's a lottery, and we picked a lottery just as a good example to show the value of blockchain. So it's, in this case, it will provide more trust to the lottery results, which means like nobody can manipulate the results. So it happens on chain, and the logic is defined by previously deployed stored contracts. So the way this application works is probably as you imagine, you buy a ticket and you get a chance to win a jackpot, which is like full price pool, which consists of ticket fees, ticket profits, and there's also a chance to get like a consolation prize, like some small amount. The application collects fee. That's kind of not necessary to the example with the application, but we wanted to show you kind of some more complex logic. And here, what you see on the homepage, you see a list of previous plays for the current round, and there are rounds of jackpots. One jackpot, when somebody wins the jackpot, a new round starts, and you can play again. So there is a page that actually lists all the jackpot rounds and the corresponding winners and amounts. So we can go inside and look a list of all plays. In this well-known Casper Click account menu, you see there is a custom menu item that says my place. You can see your place. You can switch account, obviously. So I will not, because yeah, I have a balance on this one. And it also has a link to the documentation, so we'll visit it later. But for now, let's do the demo. So before playing, I prepared this like WebSocket connection stream. So we see we are connecting to streaming API on the testnet. We are listening to contract events, and we specify contract package that this hash corresponds to the lottery app. And we use a default public access key. So let's open it. It works. And in parallel, actually, let's also open developer console. Here I go to WebSocket. So what this application does, it also tries to react in real time. So instead of like polling and checking for the state of the deploy, it will show the result in real time as it happens. So let's click play. So it opens Casper Wallet. I sign the transaction, and you see a WebSocket connection opened. So this WebSocket connection listens not to contract events, but to deploys. We wanted to show it as kind of broader example where you want to know when your deploy is executed. But in reality, for like practical reasons here, you would normally listen to events coming from your smart contract. So we see we got an event. I was unlucky this time. Let's play again. Region same channel. And let's see here. So you see in our streaming connection in the terminal, we received contract event that has lots of data. There are kind of standard properties that say what contract package hash, contract hash, and there is a user event custom event data. So here it says that I didn't win a jackpot. That's current jackpot amount after I played, play ID, player account hash, prize amount, round, and actually event name. So basically your application can have multiple events. Actually, let's also have a look. I was unlucky. Let's have a look at the deploys, maybe like this one. So those deploys are linked to Casper Live, so you can see what's happening inside. So it is a wasn't deploy because it requires native token transaction from user account. But here, what happens? So, and as you see here, I won a small amount. So we see a transfer from the account to a URF. This purse URF that corresponds to like temporary purse from WASM. So those 50 CSPR were first transferred from player account to temporary purse, and from temporary purse to the contract purse. And we also see a transfer from the contract purse, like same hash, to the account, which corresponds to the amount that was won. So if you go to the contract page in Casper Live, there is a link to the purse, and you actually can see history of its transfers. on this page. And you see like all the like 50 CSPR plays and outgoing transfers the rewards. Okay, so let's go to the presentation and so let me
just to point out, if you and I don't know if you listed the URL to this anywhere here, but this can be played with and tested out on lottery-demo.casper.network, and from there it also links to the full source code and explanation on how everything works. So it really is a good sort of, as I like to call it, like sort of kitchen sink application that combines all the various components that we've talked about, as well as the smart contract built on Odra that powers the on-chain component of it.
Yeah, so like here I want to talk about the architecture because it's very typical, and most of dApps look somewhat similar. So this example is obviously simplified, but you are limited only by your imagination. But let's start like basic components. So it has a web client, and that's where you see the app. In terms of blockchain, it creates this flow for users to interact with the blockchain. So instead of making transaction from terminal to blockchain, users have a convenient interface. So web client initiates plays which are defined by smart contract logic. When play is executed, basically deploy is processed and included in the block. The event listener part listens to contract events and stores them in the database, which provides access to index data, which you can aggregate and filter conveniently. And the API uses the data to serve back to the web application. The API also acts as a proxy between a web client and the network. And I'll explain what it means on the next few slides. So for the web client integration, we use Casper Click here, so to simplify developers' life. And on the server side, we use Casper Cloud. So actually, like API and event listener, they don't make any RPC request to the node. So the only direct request to the node happens when you submit new deploy. And API acts as a proxy between the client and Casper Cloud to hide your Casper Cloud access key, which you cannot do on the client side, so it will be visible. So that's like very typical, right? So you have some interface, you have on-chain logic, you have some kind of listener that listens to the logic and triggers like further pipelines. Very often you just like want to store and data in a way that works for you. And there is some API that reads the data. So next, let's actually look at the code and we'll cover it briefly. So the source code is available from the application here. So it is a public GitHub repository. And first you can see here, let me just open my notes because there are so many things I want to show you. So you see a documentation. We tried to cover everything we talk about in this webinar. So in a more like brief version, but you can read and follow it here. There are also all the useful links that you may want to, you may need, like to Casper Click, to Odra, to Casper Cloud. So let's, for every component that we just showed in the architecture, they have a separate directory here. So it's a mono repository. So let's just take a look at a smart contract. And let's go to, so actually in smart contract, there is also documentation that describes all the entry points, or like functions exposed by the contract. There are build instructions, how to run it locally or how to deploy it to the testnet. So if you want to play smart contracts, also a good place to start. In the source, let's actually look at the smart contract. So what I want to highlight here. So first of all, it is written in Odra, and I don't know like what languages you guys use, but you can see it is very similar to kind of this object-oriented style that like everybody knows, where a smart contract is defined as kind of this like struct class type. It has it stores data defined as properties, and it has a bunch of functions attached to it, like called entry points in Casper language. However, most of the entry points here are kind of not related to the primary logic, so it's like setup and so on. So we want to have a look at this one, which is play lottery, and you see it is like that simple. It almost fits like one screen. So let's go quickly through the logic. So what happens here? So first of all, we assert we have that payment amount was enough, but like nobody tried to buy a ticket, you know, like for less than specified. We get current round ID, we get current play ID, we fetch color, and what's happened next that we collect the fee. It's just like a variable that tracks amount of collected fees, and the rest of the funds go to the price pool. So in Odra language, we use this Odra payable, and you access the payment amount like this, cell.env.attached value. So next we defined two kind of state variables that we'll use. It's like we check if it's jackpot and prize amount. And we call this determine outcome function. It's just really kind of simple function that returns two outcomes. So you can either win a jackpot, and in this case, what happens? Like the whole prize pool is transferred to the caller, and the prize pool is set to 0. So we update the corresponding state variables and increment start the next round of jackpot. And if you didn't win jackpot, but you won a consolation prize, we again transfer tokens to your account. We deduct the prize amount from the prize pool, and we initialize the state variable. So what's important that at the end you see there is an event emitted, and that's what the event listener from the server side is listening to. And that's basically it. Right? So I want to point out that it's smart contract, and it's just like a simple code you could see anywhere. So it's like there is no nothing to be afraid of. You can basically just like start developing smart contracts right after this webinar, and you can take this one as a starting point. So let's have a look at the server directory. So it follows kind of standard server-side architecture. So it has it defines entities we operate with. It defines repositories we use to access data from the database, migrations to the database, some simple abstractions to interact with Casper Cloud, and middlewares for your web server. So here, what we want to look at the event handler, obviously. And here we see it uses Casper Cloud streaming URL. We listen to contract events, and we listen to our contract. We specify the contract hash in the configuration. And again, like it's like a very simple piece of code. So like the main logic happens here. So when you receive a message and it's not a ping, but event data, we just stored it to the database. That's it. So that's all it does. And if you look at the API, it's just a simple REST API developed with Express for Node.js, and it just all it does is just like fetches data. So again, like no nothing difficult here. I want you to pay attention to this part. So here we use API also as a proxy to Casper Cloud, and for only reason that we want to hide this access key right here. Okay, and on the client side, as previously mentioned, it was bootstrapped using Casper Click template, and it's again like typical React application. So you have scenes which correspond to your pages. You have components like reused between different pages, and there are many components only because we just wanted it to look nice. But, like the core logic is simple. So what we want to see here, let's actually have a look at the plain logic. So it is defined in services as a hook. So it's like manage play. And again, like the core logic happens here in this like start plain function. And all that happens here, you see, we read currently connected account from, actually we received from Casper Click. We get its public key. We create a deploy that calls smart contract for this account. We sign and send this deploy. So this line actually opens Casper wallet, like a wallet to use. We set state to loading. So we just like waiting for response, and we just wait for the next query deploy. So we wait for our deploy to be executed. And the logic of this function is kind of simple. So if we already have open WebSocket connection, we just set current result to null. So we just kind of nullify the previous result to wait for the new one. Otherwise, we open new WebSocket connection. And here in the WebSocket connection logic, we just have this on WebSocket message, which again, if there is a deploy, just triggers the UI that shows you if you won or if you were not so lucky. Yeah, so I don't know if you have any questions here. I also want to point out that in the main documentation, there are also instructions how to run, sorry, let's make file, how to run the whole application with all the components. So it's like, it's here. All you need Docker, and that's it. Yeah, do you have any questions?
I see one question in the Q&A that it relates to Casper Click. We'll give. Why don't we go answer that first? And if there are more questions that come in regarding Casper Cloud, then we'll switch back to that.
Okay.
David.
Okay. So the question comes from Gokai. Says, so we only need to keep users' public key on the server. We'll be sure which key has logged in or disconnected. Do we still need to create some auth key on the server side in this case? Okay, let me share my screen again. It's a very interesting question, and we can use maybe Casper Studio to answer. So here there are two scenarios, in my opinion. If your application is going to authenticate user interaction with blockchain by transactions, then I think we don't need an additional token to authenticate the user, because when the user wants to mint an NFT or transfer an NFT, he needs always to sign the transaction with Casper Wallet, right? So he's authenticating with his keeper by signing this transaction. However, when your application also manages off-chain data, then you want to be sure that the public key that has been communicated by Casper Click and sent to your server is a public key the user owns, and he can prove it by signing something like a message. And in that case, in Casper Studio, we allow the user to manage NFT collections. He can create a new collection, and for an existing collection, he can manage the assets, the footer banner, the logo for that collection. So when the user tries to create a new collection, at that point, we request the user to sign a human readable message. And by signing this human readable message, he's proving to the server that he owns this key. So at this point, so the error says I don't have balance enough to mint a new collection. But what I want to show you here is that we have now an access token that has been issued by the server, and we can keep this access token during the session between the frontend and the server. And this is needed because we are managing off-chain data. So the answer is sometimes we need a token, sometimes not. It depends on what type of data your application is handling.
Do we just to follow up on that, David, do we have an example somewhere of the sort of the use of a token for that use case?
We have example on how to sign messages with Casper Click. So when we want to sign a message, we call sign message API on Casper Click. Right now, Casper Click is not issuing the token, so that's something Casper Studio backend handles. However, with social logins, there will be tokens, and we will issue tokens for both types of wallets, social logins and standard wallets. So right now we don't issue the tokens on Casper Click. In the future we will do, and we will handle that token for the application.
Understood. There's another question. It's the question is from Anonymous, and the question is how is Condor DevNet different from Casper Testnet, and where should I test my dApp first? So here too, I wish I could like David, like it depends. This is also a little bit of a depends answer, right? So the DevNet currently runs release candidate 4 of Condor. The expectation is that there will be a release candidate 5 that will be pushed to DevNet in the near future. And it's obviously a precursor to the release of Condor, which introduces some significant changes for downstream integration. And depending on how you integrate, those changes will either affect you or they might not, right? So assuming you're working through SDKs or through middleware, those changes may not materially affect you, in which case, well, they won't affect you. If you are looking to have an application live right now and are working on it, then I would say testnet is where you want to focus. That testnet is a very accurate reflection of what mainnet looks like, meaning it runs the same version of the Casper protocol and the Casper node software. It is a highly decentralized network with hundreds of nodes underpinning it and 100 validators underpinning it. Unlike DevNet, which is a small centralized network of 5 to 7 nodes run by a single entity running pre-release software. So that's essentially the answer. So the answer is it depends. If you're working on an active application that needs to be live now and needs to be tested in a real world environment, testnet is your place to be. If you're working on an application for somewhat in the future and you're okay with updating your integration from time to time because these things are in flux as it is with pre-release software, then you can test against DevNet. I see Ihor at the ready to jump in and add some more context.
Yeah, I want to add on top of Michael's answer. So basically, yeah, it depends on how you integrate the network, and if you do it on your own using SDKs. Also 2 different networks. So like the structures change, and you would need to deal with that variability on your own. However, if you use example, tools like Casper Click, Casper Cloud, those changes will not affect you because we will mitigate them on our end. And in terms of smart contracts, again, like if you use Odra smart contract framework, your contracts remain with the same API interface, and you may only need just like rebuild them. The only thing to pay attention to is if your smart contract is using any of deprecated or changed host functions. So if your smart contract project doesn't use any of changed or deprecated host functions and you develop with Odra, you will not experience any changes as a developer. So yeah, I hope it answers the question. So I would say for most of use cases, you probably will go with testnet, unless you need to use some of the new control features. Okay, so we finished with demo. You guys probably noticed that we mentioned Casper Click and Casper Cloud keys several times. So David will just show you the Casper build console. That's where you can obtain and manage your keys and actually do a little bit more. Oh, David, you're muted.
Sorry. Okay. So basically, CSPR build is a self-registration console where you can manage, well, first get and manage your Casper Click and Casper Cloud keys. And the first thing you will need to do is to create an account, a free account on Casper build. And there are two options here. So you can register as an individual account or register as a company account. The difference will be that on the company account, you can manage different users that get access to the same set of keys and manage the roles. So some users can access Click keys, some users can access Cloud keys, or both, or different parts of the application. I will start just with the account for the make organization. What we see here is that once we sign in on the CSPR build console, we can manage our Casper Cloud keys, our Casper Click keys, and as I said, the user. So for each user, we can define roles. And for each of the Casper Cloud keys, we can see the key, or we can create new keys, and similar for Casper Click keys. Casper Click keys is a bit different because in addition to add a name for the new application, we can add some extra data. We need to define from which domains our application will work, so that we can validate the origin. We need to define for which of the networks our application is going to interact with, mainnet or testnet. And an important thing, we need to connect the Casper Click key with a previously created Casper Cloud key. And the reason is Casper Click uses some features from Casper Cloud. One example is the node proxy. When on our front end, we ask the user to sign a transaction and we want to send it directly to the node, we can use Casper Click node proxy. It uses under the hood Casper Cloud node proxy. And we connect both applications here by defining which Casper Cloud key we are going to use from this Casper Click application. Once we create a Casper Click key, we get the application ID, which is what we need to define and set on our Casper Click code. So at this point, we would replace Casper Click template with the application ID we got in the console. And that's it about the keys. Next thing here on Casper build, and this is very recent, is statistics. So we can come to Casper build console to see the usage we are doing of Casper Click and Casper Cloud resources from our application. For example, for the lottery demo application, we can check what is the usage of Casper Cloud API on testnet and Casper Cloud Streaming API on testnet. These are the two things that the lottery demo is using. And if we apply the filters, we see this chart where we see on green the number of requests per day that the application is doing to the Casper Cloud API. And here in blue, we have the usage of the streaming API. So let me disable the API, the Cloud API, to see it more bigger. And here we see that on the different days, the number of WebSocket connections that the application has done varies. So this being the development weeks of the application, there was some development here, some development here. So we see peaks here. But essentially what you get is the number of requests for each type of the API, and also you can look at the request logs. So here we see the usage of the different endpoints that the application is doing through the time. The status, all returned with 200. For the streaming, there is no status code, but we have also the duration depending on each request. And we can go through different pages to see previous requests.
Sorry, I want to add that the duration you see here is server side time. It does not include latency as the response travels from our servers to your application, but you see how fast it is actually. So that's the real data.
Mm-hmm. Similarly, for Casper Click, we can see usage statistics. And again, let's take the lottery demo to see the charts. And for Casper Click, we have two types of charts. First is the total session count. And here through the time, we see that there were 44 sessions on August 28, 68, 34. We can group by weeks. So on this week, there are 263 sessions, the previous week, 152, and so on. And we can also look at unique accounts. So this is the total number of sessions, but this is the number of unique accounts. And again, we can group by days or by weeks. And here we see that there were three different users in the lottery demo. On Tuesday, 5 users, 2 users, 3 users. One interesting data that also provides the application is the breakdown by wallet. So when we choose group by provider, we see that most of the sessions are for a Casper wallet, but we have some also for a Ledger device and some days. And for other applications, we would see also data for MetaMask or Torus or all wallets offered by Casper Click.
This is an interesting functionality, David, again, because a lot of Web3 applications have a hard time accessing analytics on who their users are and how many users they have and things like that. And through using Casper Click with Casper built, it essentially comes built in, so you have that information from a usage perspective. And on the API side through Casper Cloud, it just helps a lot with sort of debugging and optimizing your application, right? So you can see exactly what are the most frequent APIs that I'm using. If it's if there are sort of ratios there that you don't expect, you can look at your code and see, well, maybe I'm not optimized and making too many requests here or there. and you have access to data on, and I don't know if you showed that, but on the Casper Cloud side, you get access to data on error responses as well, right? So if you look at, okay, maybe if you can quickly go back to the Casper Cloud tab, and then, yeah, exactly. Thank you. And then go to the bottom, actually not that bottom, sorry, the chart, somewhere where we can group it by, instead of API, but by status, right? So we show not just whether the amount of requests, but also what the error code was. So obviously you want maximally successful responses. But in case you get high user errors or limit errors or server errors, that would be an indicator to you as a developer that there's something you need to look at in your application. That's all I wanted to point out on this. I know we are over time, so I'm gonna look for us to wrap up. Maybe a final request for questions. There are no questions pending at the moment. If there are any questions, we'll hold for a minute here. But otherwise, I wanted to thank, well, first of all, the audience of developers that showed up here. I'm looking forward to engaging even more with all of you, and we are here to help you execute your plans on the Casper Network. And as I mentioned in one of the answers to the questions in the Q&A, cost should never be prohibitive for your execution of your plans. So if there are plans that you're working on, I believe that cost is prohibitive, talk to us directly. In addition to that, we hope we have shown in this webinar, and we'll show to you in the future, that it's really our intention to make your job as easy as possible by providing you with the tools and interfaces that you need in order to most easily and most efficiently build your Web3 applications on Casper. With no further open questions, I finally want to thank Ior and David for presenting this webinar and walking us through all these topics. And again, look forward to doing this again soon. And let's keep building on Casper Network. Thanks, everyone.
Thank you.
Have a good day.
Thank you.
Goodbye.